Hi, my dear students. Welcome to Dakshin Engineering Junctions. As I have started the new initiatives regarding the revision of the complete engineering maths through the problems. So daily I am going to provide the 15 questions and the solutions will be uploaded in the YouTube channel. So today we are going to discuss about the day 1 problems we are going to discuss. So let us continue our discussion here, all of you. I hope all of you might be solved this all the problems, and let us you can verify your solutions and the key. So let's see the first problem. See this thing here. They give the two matrices A and B having the order is given. Order of A given, order of B given. You see the matrix now here, the two matrices, the order of A which is given as a P cross Q, and order of the matrices B which is given as what? R cross S. Now I want to subtract these two matrices. When the subtraction can be happens, you tell me the subtraction of the two matrices which is possible, provided so those two matrices will have the same order. The subtraction or addition is possible provided if the two matrices can have the same order, then only the subtraction is happens. So that means here this order of A is given as a P cross Q, order of B is given as a R cross S. So what is the condition for the subtraction to be valid? Possible provided P equal to R and Q equal to S. This condition must be satisfied, then only the addition or subtraction can take place. So option C. Next one. A square matrix is given the elements Aij, where Aij which is given as 0 when I is not equal to j, and Aij equal to k when I equal to j, when both are equal. And consider the square matrix. They are saying let us consider the matrix of order is 3 cross 3. Let us consider we have one matrix of order 3 cross 3 order we have considering, n is equal to 3. Now you tell me now if you have taken this as A matrices, now you can tell me which is equal to the elements which we can take A11, A12, A13, right? A31, sorry, A21, A21, A22, A23, A31, A32, A33. This is the 3 cross 3 matrices. And what they are saying here, when I is not equal to j, the element is 0. So here I is not equal to j, so this element is 0. Here I is not equal to j, this element is 0. Here also I is not equal to j, this element is 0. I is not equal to j, this element 0. I is not equal to j here. Here also I is not equal to j. And when I equal to j, that element is given as a k. So this element is what you tell me? K. And this element is k. And this element is k. So from this matrix, which we can write this thing as, tell me now here, k 0 0 0 k 0 0 0 k. So this is a matrices we got. You see this thing carefully. 3 cross 3 matrix we have taken. Only diagonal elements are k, some constant. This type of matrix, what I should call this type of matrices is a scalar matrices. This type of matrix which is called as a scalar matrix. So option D. Next, see the next problem, and this problem also similar to the earlier only. So the square matrix they are saying of order n cross n. Now this aij which is equal to k for I is equal to j, and which is equal to 0 when I is not equal to j. So this is exactly same data they has provided for the like a previous problem. Now I can simply copy this and I can consider this matrix like this here. Now this is the matrices now here, 3 cross 3 matrix. So now you tell me now here, trace of the matrix we need to get. What is the trace of a matrix, you tell me? The trace of a matrix which is nothing but sum of the principal diagonal elements. Trace means what, you tell me now? Sum of the principal diagonal elements are called as a trace of a matrix. So here in this case we have taken it as a 3 cross 3 we have taken. So which is equal to the answer which is equal to 3k. The same thing if I consider the matrix of order n cross n matrix, can you tell me the trace of the matrix? The trace of the matrix which we can get this thing as, tell me now here. So this is n into k. So option A. Next, and you can see now here, see the next problem, d1 d2 are the diagonal matrices and they given this as MSQ, multi select on question. d1 d2 are the diagonal matrices. And what are the diagonal matrices? First of all you tell me. d1, if I say d1 is a diagonal 3 cross 3, if I consider elements which might be in the form of a comma 0 comma 0, we have only diagonal elements are non-zero. At least one of the diagonal element is non-zero. So 0, 0, 0, C. So this I can say diagonal matrix D1. This diagonal matrix is D1 in short form, which we used to write this thing as what? Diagonal of only principal diagonal elements only we can write. Remaining elements are 0, you can see. And D2. So let us consider which is of the form x comma 0 comma 0, 0 y 0, 0 0 z. Consider the matrices is like this. Now this D2 in short form, how we can write, you tell me? Diagonal matrix of, tell me, x comma y comma z. These are the diagonal matrices. Now you tell me now here what they are saying, the one by one option you see. D1 into D2. Check this thing whether this option true or false. That means we have multiplied the D1 D2 matrices, we have multiplied. We multiply these two here. Now so this matrices which will get in the form of diagonal form only हमको मिलेगा. We'll get it in the form of diagonal form only. Check this thing here, which will get this as AX, next BY and CZ. Next D1 plus D2. Sum of the two diagonal matrices. If I add, so you tell me now what will get now here. A plus X will come. Only diagonal matrices, that is B plus Y will come and C plus Z will come. Next option C. Tell me option C what they given, D1 square plus D2 square. If we multiply these two here, what I will get, you tell me, D1 square plus D2 square. If we multiply these two matrices, so here D1 square if I do, it is the matrix D1 multiplied with itself only. So which I will get this as A square, B square, C square plus and D2 square, X square y square z square. So if I add these two here, what I will get, you tell me? A square plus x square, diagonal matrices. I can write diagonal. Since it's a diagonal form only na. So this is a diagonal of what I will get, a square plus x square. Fine, let us move to the next page here. So here this option C, we have d1 square plus d2 square we are doing. So you tell me now what I will get, d1 square. So which is, we'll get it as a diagonal of a square b square c square plus diagonal matrix of, tell me, x square y square z square. By adding these two here, what I will get, you tell me now here, diagonal matrices of a square plus x square, b square plus y square, c square plus z square. Done. Next. And so here they given the option C also correct. Option D, you see this thing, D1 transpose plus D2 transpose. If you see this thing here, D1, which we have as A 0 0 0 B 0 0 0 C. If I take the transpose of this matrix, can you tell me now any change by taking the transpose of this matrix? Only principal diagonal matrices elements are there. Principal diagonal elements does not change by taking the transpose now here. So that means D1, which is exactly same as what I can write now here, diagonal matrices of A, B, C. No change in a transpose also. Tell me now D1 square, D1 transpose. Now, so D1 transpose plus D2 transpose we need to find now, tell me. If I find the D1 transpose plus D2 transpose, which is given as diagonal matrices of D1 is A, B, C plus, so second matrix, diagonal matrices of, tell me now here, which is x, y, z. If I add these two here, tell me what I will get now here. Same diagonal matrices only will come, you tell me. That is A plus x, B plus x, C plus z, B plus y. So that means this D also correct now. So which are the correct statements, you tell me now here? All are correct. A, B, C, D. So this is a MSQ question. Next, now you can see now here, if AB equal to 0, then what happens? If AB is equal to 0, is it necessary that, so matrix must be null matrix? If A B equal to 0, the A matrix may not be null matrix, B is also may not be null matrix, isn't it? So let us consider one simple example here. Let us say A matrix is 1 minus 1 0 0, consider, and the B matrix we have assuming this thing as something 0 1 0 1. So A is not a null matrix, B is also a null matrix, not a null matrix. So let us find out the product of these two matrices. 1 minus 1 0 0. Next B 0 1 0 1. So here multiply these two, and this rows we have multiplying with these columns. Tell me now here 0 0 1 minus 1 0 plus 0 and 0 plus 0. So the product of the two matrices A B, which is a null matrix, you see, null matrix. So that means even though A and B are not a null matrices, the product may be a null matrix. For this AB to be 0, A and B need not to be a 0 matrix. If any A or B is 0, then definitely it is 0. But even though even A and B are need not to be 0 cases, also product may be to be possible to be 0. Right, these are the linear algebra problems. Now let's see the probability problems. So let's take the probability problem. If A and B are the two independent events, then the probability of occurrence of at least one. So first of all, they given the condition is the two events are what you tell me now here. A and B are independent. A and B are independent events are given. Right. So that means what I can say here, P of A intersection B, which is equal to P of A into P of B, since both A and B are independent events. And the probability of occurrence of at least one of A and B. They are asking for what you tell me now, the probability for what? At least one. What is the meaning of at least one here? Yes, what is the meaning of at least one here? Either A or B or both. A, B or both. So at least one, which is nothing but P of A union B. At least one का मतलब क्या है? So that is nothing but P of A union B. Either B or A or B or both also. Right. Now you can see now what is P of A union B. P of A union B, which we can write it as 1 minus P of A union B whole bar, I can say. P of A plus P of B equal to 1. And so according to De Morgan's law, so here P of A union B whole bar, which is equal to what we can say here, P of A bar intersection B bar, so which is given as 1 minus P of A bar intersection B bar. Since the two events A and B are what nature here? A and B are independent here. So we know the condition. If A and B are independent events, if A and B are independent events, so what are the condition you see? The first most important thing here, A bar and B are also independent. Next one here, A and B bar are also independent. Third one, A bar and B bar are also independent. Isn't it? If A and B are independent events, A bar and B, and A and B bar independent, A bar and B bar is also independent. Here, so A bar and B bar independent, so I can write this thing as P of A bar intersection B bar, which is given as what I can say here, P of A bar into P of B bar. So that is 1 minus, I can write this thing as P of A bar into P of B bar. So option A. Next, If A and B are two events in the sample space, yes, then P of A union B is. Now, as we know, P of A union B, which is equal to what? P of A plus P of B minus P of A intersection B. So here if we observe the things, you see this thing here. Now if we see carefully, this is P of A plus P of B. The sum of these two fellows, which is equal to what, you tell me? P of A union B plus P of A intersection B. Yes, that means if you observe carefully, so the sum of these two, which is equal to sum of these two here. Understood? The sum of these two fellows, which is equal to sum of these two fellows. Now if I remove this thing here, then what happens now here? Then this value will be more compared to this thing. Now tell me. Means what we can say here, P of A plus P of B, this value greater than or equal to P of A union B, I can say. So from this, finally what I can conclude, you tell me now here, that is P of A union B, which is less than or equal to P of A plus P of B. So see the option now here, third one. Next, here you see this thing, A is a subset of B. That means whatever the elements in A, all are available in the B. So means what I can say here, A is subset of B. So if I have taken the A intersection B, here which is smaller value, A is small, B contains all the things of A. In addition to that, it will contain some more also. What I will get, intersection between these two here, which I will get this as A. Then tell me now here, P of A intersection B, which is given as P of A only. Right. Now you see this thing here, P of A intersection B bar, means what now here, we need only A. So the P only A, which is nothing but P of A minus P of A intersection B. Right. Now you can tell me now here, P of A intersection B bar, which is given as, that is P of A minus P of A intersection B, which is nothing but P of A only now. So this value, which is equal to 0. Next, if A and B are exclusive events in the sample space, then now what they are saying is that A and B are exclusive event, then there is no common thing between A and B. So that means P of A intersection B is 0. As we know, P of A union B, which is given as what? P of A plus P of B minus P of A intersection B. Since A and B are exclusive, the intersection, which is equal to 0. So what I can say now, tell me now, P of A plus P of B, which is equal to P of A union B. As we know here, the probability of any event, maximum value of probability of any event, which is always less than or equal to 1. Maximum value of the probability of any event which is equal to 1. The probability can be less than or equal to 1. So I can say here P of A plus P of B, which is also less than or equal to 1. So according to given option, I can rearrange the relations, which is given as less than or equal to 1 minus P of B. So then P of A, which is less than or equal to 1 minus P of B, which is nothing but P of B bar. So this is a relation. So first one is correct. And next, an unbalanced coin is tossed n times. The probability that head will present itself odd number of times. Odd number of times means what? Head will appear odd number of times. One time. Excuse me. The first time. Next third one. Next fifth one, like that. Here this is a finite number of times. So here we use a binomial theorem we use. Look at now here. What is the probability of getting head? That is 1 by 2. And what is the probability of not getting the head means tail, which is also 1 by 2. Which is also 1 by 2. Right. Now, I need to get, so odd number of times means what now? I should get the probability here. It should be a probability of getting head odd number of times, which is given as first time. So means what we can say when I toss it now here, NC1 into what I can say here, 1 by 2 power 1 and 1 by 2 whole power, remaining times are n minus 1 plus. Next I need to get NC3, third time I need to get, that is 1 by 2 whole power 3 and 1 by 2 whole power n minus 3. Next I should get the fifth time, that is 1 by 2 whole power 5 and 1 by 2 whole power n minus 5. Like that will come, you see. Now if we observe carefully n times, NCN, like that. And if we see carefully now, this is nothing but NC1 into 1 by 2 whole power n plus NC3 into 1 by 2 whole power n and NC5 into 1 by 2 whole power n. Like that will continue. Last term will get NCN into 1 by 2 whole power n will come. And if you see carefully now here, I need to get odd thing now, so that's why we got like this. If you see carefully, I can say 1 by 2 power n is common. So that is 1 by 2 power n is there common. So which will come it as NC1 plus NC3 plus NC5 plus NC7, like that we have the sum of odd binary coefficients, which is nothing but what you tell me. So here the sum of, as we know, NC1 plus NC3 plus NC5, yes, like this, the sum of odd binary coefficient, which is given as 2 power n minus 1. The sum of odd binary coefficient, the same manner NC0 plus NC2 plus NC4, the sum of even binary coefficients are how many? Which is also equal to 2 power n minus 1. So then what is the probability, you tell me here, which is given as, that is 2 power n minus 1 by 2 power n is common. So which will get this as 1 by 2. So option 3, third option. Next problem, see this thing. Yeah, we completed the probability problems. Now we are entering into calculus problems. Let's see the first problem. Limit x tends to 0. So tell me now here. In this case, limit x tends to 0, 1 plus x whole power k. So this is, we have a 1 by k minus 1 by x. Now if a substitute will get 0 by 0 form, so we'll go for L'Hospital rule, that is 1 by k into 1 plus x whole power 1 by k minus 1 minus derivative 0 by 1. Now substitute x is equal to 0 here. Now that is 1 by k into, this is 1 power 1 by k minus 1, which is equal to 1 by k. So what's the option, tell me? Third option. Next. Now if I substitute directly 1, we'll get, here also we'll get 0 by 0 form, we'll get it now. So what I can do here, we'll go for L'Hospital rule. Tell me now here, that is limit x tends to 1, so which is 2x minus 3 into root x, that is 1 by 2 root x minus 0, yes, plus root x minus 1 into 2 by denominator is 4x plus 1. Now if I substitute directly x value equal to 1, so then this term will become 0 now here. This term will becoming 0. Now you see this thing here. So this is 2 minus 1 here, that is minus 1 into 1 by 2 plus 5. So what I will get now here, minus 1 by 10 will come. Next, next problem. And here also if I replace x is equal to 0 directly, we'll get 0 by 0 form, we'll get it now here. So what I can do here, and here also we'll go for L'Hospital rule. Tell me now here, limit x tends to 0, this is 1 plus sin x. 1 plus sin x whole power 1 by 3 minus 1 minus sin x and whole power 1 by 3 by x. Now tell me what I will get. L'Hospital rule, that is 1 by 3 into 1 plus sin x whole power minus 2 by 3 into sin x derivative is cos x minus, and 1 by 3 into 1 minus sin x, which is equal to minus 2 by 3, and sin x derivative minus sin x, so the derivative is minus cos x by denominator is x. Now substitute x is equal to 0. When x is equal to 0, so then see what happened now, tell me. So this term sin 0, which is equal to 0, this term 0, cos 0 is what? 1, and this term is a 0 and this term is a 1. Yeah, so denominator which is equal to what? This derivative we did now, so this is 1. Now simplify, what I will get, you tell me now. This is 1 by 3 into 1 minus 1 by 3 minus 1 by 3 into what you will get, you see this thing carefully again. So here minus or minus plus will come now by 1. So which is equal to 2 by 3. This is answer. Next, limit x tends to 5 x power k. I hope you might study everybody. Limit x tends to a x power n minus a power n by x minus a, which is given as n into a power n minus 1. If not, we can apply this thing simply. L'Hospital rule will get. Simply apply the L'Hospital rule here. That is k into x power k minus 1 minus 0 by 1 minus 0. And what's the limit you tell me now here? X tends to 5. Replace now here. That is k into what we can say. So that is 5 power k minus 1, which is equal to 400. Yes, so that means k into 5 power k by 5, which is equal to 400. And you can see now here, that is k into 5 power k, which is equal to 2500. So we can verify the option value. So what value of k can satisfy here? Which is equal to 4 will satisfy now, tell me. So 4 is the answer. Next. Now you see this problem. If I substitute the values directly, x value will get 0 by 0 form. So let us simplify this equation little further. X tends to 1, which we can say this as square root of x minus 1 into, so here x plus 1. I can remodify this thing as x plus 1 plus square root of x minus 1 by, so square root of x minus 1 into x plus 1. Now if I take x minus 1 common and will get cancel it, then the what we have left out in the numerator, you see, that is square root of x plus 1 plus 1 by square root of x plus 1. Now substitute now here, that is root 2 plus 1 by root 2. So this means what I will get? 1 plus 1 by root 2. So this is the option. Done. So I hope all of you understand all these problems. Fine. This is the day 1 solutions. And next, all of you do like, share and subscribe to the channel, and I will regularly do the solutions. All the solutions will be provided in the channel. And the next class you can find the day 2 assignment, day 2 solutions you will get. Okay then, see